2212, Lab 3, Circuits. Here's a brief overview of my entire lab. We're going to begin with an introduction, then we're going to get into the physics involved with the lab. Then we'll look at our observations and the results, which have kind of been combined into one section in this lab. And then some key takeaways, answering some fundamental questions about the concepts that we deal with here. Introduction. Purpose. The purpose of this lab is to gain an understanding of the behavior of circuits in series and in parallel, to measure actual values of current and potential difference using multimeters, being voltmeters and ammeters in our case, and examine the behavior of resistors and capacitors. Results preview. The node and loop rules both hold true in this lab. Physics involved. Fundamental principles and equations. So the node rule being the sum of all currents flowing into a node is equal to the currents flowing out of the node, and all currents surrounding the node equaling to 0. The loop rule being the sum of electric potential difference around a node is 0. And Ohm's law being V equals I times R, or current times resistance equals voltage. Pre-lab. Prediction of the circuit given in our lab instructions. The current in both is equal to 20, or the current at both ammeter sites is equal to 20.41 milliamps. Observations and results. The prior mentioned circuit in the lab and measured using the multimeter. The current in both at both sites is equal to 19.3 milliamps initially and negative 19.3 milliamps when measured backwards. The multimeters from the ammeter setting to the voltmeter setting. And we found that the circuit had a voltage of 0 and 19.8 milliamps. Circuit. The sum of the potential differences across the circuit should be equal to 0, and ours actually ended up being equal to negative 0.2 volts. And then here's a graph of our voltage potential across the circuit. Pre-lab circuit. Resistance calculations. The 100 ohm resistor we found was equal to 98.44 ohms, and the 47 ohm resistor we found to be equal to 46.63 ohms. The multimeter equals 33.33 ohms. The error in the resistors could be due to a number of things. Most likely unfound resistance in the actual circuits, or inaccuracies with the multimeters. And the multimeters resistance read 33.33 ohms. And then this is a image of the calculations and the timings we found for the capacitor. Key takeaways. What if you charge the capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this happen in real life? The ideal model would predict that the capacitor would charge instantaneously, but in reality, the wires and the internal battery have their own resistances, so it would not be instantaneous. Thank you.